All right, so here again, the example, they're going to say something about find the exact value. Now, the problem again, 105 degrees is not on the unit circle. 15 degrees isn't either. So this is where using the sum identity is awesome. So what I would do here is I'd be like, okay, I don't want this. So instead, I'm going to split it into cosine. And you have to think of things that add up to this that are on the unit circle. So I have 60 and 45 kind of come into mind, especially with that 5 there. 45 kind of jumps out at me. You might try 90, but then you're like, oh, 90 and 15, not so much. So you want to break this into something that is on, the angles are on the unit circle and it's a sum. Now, again, there is no distributing a function over the input. That does not make sense. So you need a trig identity to help you with this. So again, that would be cosine 60 cosine 45 minus sine 60 and sine of 45. All right. And so just keep track of what your alpha is, your betas, and sub those into the formula. Now, all of these guys, this will spit out a ratio. This will spit out a ratio. This will spit out a ratio. That will spit out ratios. So that's where you can use your unit circle to look. So I get a half square root of 2 over 2 minus square root of 3 over 2. So having your unit circle handy is awesome. And then at this point, it's just fraction work. So I get square root of 2 over 4 minus square root of 6 over 4. And you have a common denominator. And so I get that. And again, do not convert that to a decimal. These do not add. They're not like terms. So you stop. All right, this one, kind of the same idea. Now, this one, you can have a couple choices. You could do, if you had adding in your brain, you could use cosine of 60 degrees plus a negative 45 degrees. Now, if you're going to do that, and this is your alpha and this is your beta, that negative goes with you, so you got to watch that. So that would be like cosine of 60, and then cosine of negative 45, and then minus sine of 60, and then sine of a negative 45. All right, and so you really have to, you know, when you look at the unit circle, you just have to watch that. Now, again, this will spit out a ratio, 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 ratio. So you'll get like a half times square root of 2 over 2. And then there's a couple things you can do here. You can either look up the negative 45 if you want. The other option is sine is an odd function. So if you remember that and you're like, well, I don't want to minus and then look up negative 45, you could just say, well, I'm going to make this actually a positive 45 and bring that negative out there and make that positive. That would work also because it is a negative function, all right, or an odd function. So the negative sticks with you. So you could do that. Otherwise, you can just leave it minus and look up the, you know, you could leave it minus and have your sine of 60, which is what, square root of 3 over 2. And then your negative 45, you can come down here and say, oh, well, let's see, I have square root of 2 over 2 and negative square root of 2 over 2. So sine is negative down there. And then you can just use the negative. That's okay. But notice the same thing, you get the same answer if you took the negative out from the odd function and made this plus. And then you're looking up here at a positive 45, and then that would be plus. So it's not going to change your answer either way, how you view it. Again, you're going to end up, you know, doing some fraction work here, which is pretty typical. And you can see we get a lot of square root of 6s and square root of 2s. Very, very common. All right, so that's my final answer. So again, you have some options there as far as how you do that. Let's do one with radians real quick. So I'm going to erase this jazz, and we will do one with radians. And then we can do this backwards too here. Sorry. All right. Sorry about that. Hopefully it didn't hurt your ears there. All right, so with radians, you still, you know, it's still an angle, so it doesn't matter. All right, pi over 12 is not on the unit circle. I can kind of guess. I mean, it's, you know, pi over 6 is here, so this is pi over 12. So that's like a 15-degree angle. But I want to do this in terms of radians. So you have to kind of think of, you know, what are these guys in terms of radians, right? So, you know, we have pi over 6, we have pi over 3, we have pi over 2. So we have some different options. And again, more than one might work, all right? So, but I'm going to get a common denominator of 12 on all these guys just to kind of see how that might help me. So this would be what, 6 pi over 12, let's see, times 4 times 4. This would be 4 pi over 12, and then times 2 and times 2, 2 pi over 12. Let's see, what else do I have here? Oh, I forgot the guy in the middle here, sorry. All right, so pi over 4 would be what, times 3, so that'd be 3 pi over 12. So I could use, you know, this and this are 1 apart, or I could use this and this. Those are 1 apart. And so, you know, sometimes it's just personal choice. I'm going to use, let's see, 4 pi over 12 minus 3 pi over 12. All right. And basically, you know, that's the same if I reduce that. That would be pi over 3 minus pi over 4. But again, you know, I kind of, to try to figure out what subtracts or adds to that, I need that. All right, so again, if I'm using subtraction, if I'm not using plus and negative, then I have to use the subtraction formula, which would be cosine pi over 3, cosine pi over 4, plus sine pi over 3, and sine pi over 4. But again, if you want to do plus and negative, that's fine. Just use the plus formula and then make sure you have a negative angle in there. All right. So at this point, again, spits out a ratio, spits out a ratio, spits out a ratio, spits out a ratio. And all those ratios will be on the unit circle because obviously I want an exact answer. And so your calculator is really not going to do you a whole heck of a lot of good on these. All right, so just multiply and you're like, oh my gosh, I keep getting square root of 6s and 4s and square root of 2s, and that is correct. I have a common denominator, so I'm just going to do that. And again, these are not like terms, so that's my final answer. All right, one more thing I want to do on this video quick, and then I think we will be done. If you need more time on that, you might just want to pause it or go back and watch it again and then just pause it before I erase. All right, last thing is you can do this in the opposite direction too. So say I give you cosine of, say, 49 degrees, cosine of 4 degrees, plus sine of 49 degrees, and sine of 4 degrees. So when you see anything, again, cosine, cosine, sine, sine, cosine, sine, sine, cosine things, you know it's the cosine of alpha plus beta, or alpha minus beta, or sine of alpha plus beta, or sine of alpha minus beta. It's going to be one of those. And so I look at this and I'm like, okay, well, this is my alpha, alpha. This is my beta, beta. And I look at the formula and it's like cosine, cosine, sine, sine. So that goes with cosine of alpha minus beta. All right, that's the trig identity that goes with that. So now this time I'm going backwards. So this time they did the math out and I'm undoing it. So that means I would have cosine of alpha minus beta. And again, the directions are going to be to find the exact angles. Well, again, you can't find a ratio to these guys on the unit circle. So you know you have to undo it, which is 45 degrees. And so then I'm like, oh, awesome, you know, cosine of 45 degrees, that's square root of 2 over 2, and life is good. And again, remember, angles, sine, cosine, tangent, they spit out ratios, so your answer should be a ratio. And I could do the same actually with radians, so you could have cosine of 1, oh, sorry, cosine of 2, and cosine of a negative 3, minus sine of a negative 2, and sine of 3. Again, radians, we don't know what these guys are on the unit circle. On this one, the problem is if you're like, well, awesome, this is, you know, whatever. Well, this is alpha, and that doesn't match that. So basically, I have alpha, beta, and then like gamma and theta. I have different angles here. So you can't have that. So if you're going to use this rules, your alphas have to match, and so do your betas. So this is where even and odd functions come into play. All right, so if I look at this, I'll stick with red. Cosine is an even function. So that means that negative can, I mean, just disappear basically, because it's, if I sub in a negative angle, I get the same as a positive angle. So that one, cosine, is an even function. So I'm just going to make it positive. Sine, on the other hand, is not. It's an odd function. I always remember that sin kind of sticks with you. Again, you can make up your own little trick, but that works for me. So I can take the negative out, but it's going to make this the opposite. So that actually becomes positive. All right, now when you look, now you have alpha, alpha, beta, beta. So now you can use the trig identity. All right, so again, none of these are on the unit circle, so you're going backwards, all right? So then I'm going to get cosine of alpha minus beta. And again, I'm just using radians this time. So 2 minus 3. I get cosine of a negative 1. All right, now again, even odd functions here, even functions. So again, this guy really doesn't matter. All right, so it's cosine of 1. All right, and that's the best I can do. If I don't want you to use a calculator, you know, this is what, 1 radian, so about 1 radius. If you measure a radius up, you know, it's about there. It's probably, I don't know, what is it, 67 degrees? I can't remember, 50 some. But you know, it's around that a little bit, 60 degree-ish, plus or minus a little bit. But I don't know what it is exactly. I'd need a calculator on that one. So I am just going to leave it there. Again, if I did type in cosine of 1 radian, now remember, that's not the degrees it's going to give me. It spit out a ratio. So if you do your bow tie there, it would give you the ratio of, what is that, adjacent over hypotenuse.